Okay, we're going to build up some of these ground fault circuits here and see what happens. So here's my circuit right here. The first thing I need to do is hook up my transformer, and it looks like I have a stop-start typical holding circuit right here. So that's the first thing I'm going to do. I'm going to come and I'm going to go with my power supply. And I always like to just come to the voltmeter here real quick. Click it on, be sure I do have voltage. And then that gets jumpered up to here on my primary. And we're stepping the voltage down to 12 volts. So it's those two and those two. So there's my configuration for my primary. And then I have my voltage right here. So I'm doing a standard stop start. So I'm going from line 1 to a normally closed stop. And then I'm going from a stop to a start. And then I was going to go from the start to the control relay. And then I would come back to the voltage. Okay? At this point, I can check it. I should not have memory. I'm just getting my relay. I don't have any memory, so that's working. I want to go ahead and run my memory next. So what I'm going to do is I'm just going to stack on top of the start right here, one on each side. And these go to the holding contacts on the relay, which would be here and here. Those are my open. So at this point, if I check it again, I have start, it's on, stop. Okay, start, stop. That's working great. Okay. The next thing I have to do is I have to run these lights across here. Okay, so I'm basically going from line 1, and I got a couple lights in series. Now, these are LED lights, so they're not going to be as dim as a normal light, but they're going to be in series. So I've just got that from there to there, and so I've got my voltage jumping across, and then this side jumps back to the other side. So if I go ahead and I turn this on, these lights are on, and they are a little bit dimmer. I can show you. If I just unplug this one right here and plug it in there, you can see that that is definitely brighter than that. That's brighter than that. So these are a little bit dim, okay? So here we go. Let's figure out what is going on with the ground faults. It says a ground fault to A or B. I guess either one of these, because the stop is closed, with stop not activated. So what I'm going to do is I'm going to go and I'm going to ground to that point. Now remember, the electricity wants to flow from line 1 and it wants to get to line 2, and it wants to take the path of least resistance, okay? So the first thing I'm going to do is I'm going to take a point between these two lights. Let's find that point, and it looks like it's that yellow jumper there. It could be this one or this one, either one of those. So that is that's my my ground. It's simulating my ground. And in this case, I'm going to go to one side of the stop button. So it doesn't matter which stop, because it said A or B. So I guess I can go on to either one of these. But if I go here, let's see what happens to the lights. Okay. So when I got my ground there, I got one light to come on, really bright, and the other one went off. How come? Well, without this, the electricity passed between these on this rung here, and these were half as bright because it was in series. The load was in series. But now when I got my ground here, my path has the following option. I could come through the push button that's closed and go to the ground, all right? Or I could pass through the light to get to there. So I take this off. Oops, sorry. If I take off this, that's when it's passing. It's taking the path through the series. But once I put this ground in, and it takes the path of least resistance, well, this wire right here has no resistance. This light has some resistance. So it's going to take this path over the path through the light, and then it's going to go to the light, and then this is going to become bright, right there, okay? Because there's no longer two loads in series. This is just a normal load from line 1 to line 2 with a load. Now if I were to push the button the way that I've got it set up, the stop button right here, that would then open up. This would open and open up that rung, and you notice that both of these then go back to dim and dim, okay? So that was the first one. So let's go ahead and pull this back off. The next one was a ground fault to C. So I got a ground fault to C right here with neither one of those two activated, okay? So let's think about it. Once again, we want to get the voltage from the left to the right. The voltage is not going to flow backwards, or it's not going to flow backwards here. It's going to flow from line 1 to line 2, and it's either going to pass through the lights or the loads on this side, okay? So here we go. It says I'm going to make that ground fault to C, which is on the other side of the start button. So if I come and I grab my ground fault here again, this is on the other side of the start button, okay? And so what happened was I got the second light to go off this time, okay? Let's figure why that is. So once again, without this on, the path comes through both of these and they're dim because there's two loads in series, okay? But when I got this ground fault, it wants to get over to here, so it's going to come there. Now, it's got a choice. Should I go through the control relay, or should I go through the light here, okay? And we already talked about that when you had a control relay and a light in series, that the light was going to come on bright because of the resistance difference between the control relay and the light. So it's going to come this way, okay? This is going to have less resistance here as compared to this, so it's going to want to take the path of least resistance. And when it does that, there's not enough voltage across this light or enough voltage across this relay to turn these on. Instead, all the voltage end up dropping through the first light there. And then this, as we did the math, this gets quite a bit of voltage. This doesn't get hardly any voltage, and this is the path of least resistance. So this one here ends up not turning on because it's going to take that path, and that's what we have right there. Okay. The next one was a ground fault to C. So there we go again. We haven't pushed the stop, but now I'm going to push the start. All right. So I'm going to go ahead and I'm going to push this start. And I got the relay to come on with a light switch. So at this point, I have my memory. So there's my stop, no memory. There's my stop with memory. So let's figure out what's going on there. Well, because I have memory, that means that this is closed. I have a path around the bottom there where the memory is. Okay, so now, what's my path of least resistance? My path of least resistance, I can either go here, or I could come through a load. Well, there's no load here, it's just conductors. So the current's going to want to flow this way instead of flow through there, okay? And at that point, I then have two loads basically in parallel because I've got voltage here and I've got voltage there being delivered. And so we know that when you put loads in parallel, the voltage drop is going to be the same. So it'll find its way through the control relay, and the control relay is on, and it will find its way through the light, and this light is once again bright. Okay, so these were the brights, bright, and depending on what we had set up, it changed these from these lights just being dim in a state that was working, and like this. Go ahead and unplug that. Notice with my control relay on, my stop start, oh, it's pulling the voltage down a little bit. Basically, those are staying dim. It's only when you get that ground fault. It's only when you get that ground fault here that something happens. And based on how you think about this, and in your intuition, you can say, okay, this one's bright or that one's bright. I've got a short on kind of the input side of this circuit, or I got a short on kind of the output side of that circuit based on what the lights are showing there, and that will help you troubleshoot your problem.